He'll be a good team.
He'll be pretty good next year.
You know, we always say they're going to be good next year.
Oh, really?
No, Ryan's son is taking over the franchise. We might see a pennant in the next 5 years.
Yeah, in other people's stadiums. Now, let's look at multiplying 5x plus 2 times x plus 8.
It's frozen.
Yeah.
You're frozen.
I won't help you out anymore.
I would have figured it out eventually with the looks on your faces, I hope. Now,
Is there another distributed way we can work that besides one you showed us?
yeah, no, this is the way that I typically will work the problems if it's just me by myself. I will take this, and I'm just going to distribute. I'm going to take the 5x, I'm going to distribute it to the x, and distribute this to the 8. When I distribute, what do I have?
5x squared plus 40.
5x squared plus 40x, right? But then I have to distribute the other piece, right, the 2? So I'm going to take my 2 and distribute that to the x and to the 8. Now here's what I want you to be careful about. This is the way I like to do it. Take it or leave it. But when I do the 2 times x, I get 2x, right? I'm going to put it underneath the 40x. Why am I doing that? Because they're like terms, right? Create those columns for adding like terms. And then 2 times 8 is 16. So you combine like terms, and you have 5x squared plus what?
42x.
Plus 42x plus 16. Do y'all agree? Everybody excited about that
Can
one?
we just
I like
do
that
the
one.
box method?
Yeah, you can do
we
the.
choose either one?
You can. It doesn't matter what method you use. If you want to do it this way, if you want to do the box method, what we're all about is making sure that we can get the correct terms. The way you choose to organize them is up to you. Okay? But you want to pick something that makes sense to you. Okay? Don't make this more difficult, because it really isn't difficult. Now, speaking of the box method, and going back to a question that you had before, Greg, I'm going to do the box method with this problem, and I'm also going to do it the way I did it this way up here. I'm going to show you 2 different ways, and you're going to see the organization is exactly, it ends up with the same terms, but it just looks a little bit different. So take this 2x and distribute. So when I distribute, what do I have there with that 2x? 2x to the third, then what?
6 plus 6x squared.
6x squared, and then minus 8x. Then I'm going to take the negative 9, make sure you understand it's a negative 9, and multiply that out. What do you get? Notice where I put my minus 9x squared. Okay. Now, you don't have to put it here. If you want to put it out to the side here and keep on going with a string of terms, you can do that. However, if you make a mistake, it's very difficult for anybody to find out where the mistake was made. Okay. But if you do it in a way like I'm showing you, it's really easy to figure out if something goes wrong. It's easy to find it. Keep distributing the negative 9. What do you get? Minus 27x, and then what?
Excuse me, minus 36.
Plus 36. Do y'all agree?
Yes.
Okay. Combine these like terms. Should be easy because they're in columns. What do you have? 2x to the third minus 3x squared minus 35x, and then plus 36.
So you always want to descend your greatest exponents to your...
Right, it's called descending order. When you start with your highest degree term and you just work your way down till you get to the constant, which has a degree of 0. Exactly right. And that's a pretty standard way for writing polynomials. And when they're not written in descending order, you might do better off to rewrite them, especially when we start talking about factoring in the next chapter and other things that you'll see in the next class. If it's not written in descending order, it throws you off. But you know what? You have the option of rearranging terms. Okay? But let me show you what the organization would have looked like if you had done the box method on this guy. with the box method, and this is the way I like to do it, take the larger polynomial, in this case the x squared plus 3x minus 4. I put that across the top of my box. How many columns will I have with this guy?
3.
3. Now how many rows am I going to have?
I did it the other way.
Well, how many rows am I going to have this way?
3. Oh, 2.
I'm going to have 2. 1 row for each of these terms. Now, if you put 2x minus 9 across the top, you would have had 2 columns, and this guy would have been down the side, you would have had 3 rows. But the terms on the inside would have been exactly the same. And let's see if we can figure out what those terms are. So we've got my 2 rows, and I've got my 3 columns. So what term do I have here?
2x to the third. No.
2x to the, you're right, 2x to the third. You see you've got x and x squared. How many factors of x are there together? 3. Then what?
6x squared.
Plus 6x squared, and then what? I was wrong, try again.
8x.
Minus 8x. Does that looks really familiar. Have I seen this line anywhere else?
Yeah.
Didn't I see it right here? It's the exact same thing. Keep going. What's down here?
Minus 9x squared.
Minus 9x squared.
Minus 27x.
Right, minus 27x and
30.
plus 36. It was the same line we had here, right? Now you'll see that your like terms are lining up on those diagonals, right? Now, the only difference between the box method and what I had done the first time is that there's a little shift that's been happening here. Like if you took this bottom row right here and you just shifted it over one, you would have everything lining up in the columns that I had before, right? So you're still going to get the same answer. It's just a different way of organizing. And let me tell you this right now when you're doing this multiplication with these polynomials, if you mess up one sign or one number, it will mess up one of your terms. However, if you mess up one exponent, you mess up a power, you're not just going to be messing up one term. You'll probably be messing up 2 terms if you do that. So make sure that you're very careful about everything you do here. And something else to notice, that this is what I would consider a normal polynomial in descending order. A degree of 2, a degree of 1, the constant has a degree of 0. Do you all agree? When I multiply times that, notice the degrees of these terms. It goes from a degree of 3 to a degree of 2 to a degree of 1. It steps down by 1 every time, the same way that guy did. So that could be a quick little check to make sure, are my degrees correct? Is it lining up the way it's supposed to?